Assalamu alaikum, ni ne Abubakar Abdulhamid MB. A bidiyon mu na baya mun riga mun yi derivative da dukkan methods ɗin da ake differentiation, quotient rule, product rule and the chain rule. So yau za mu amfani da derivative in graphing mu ga ya ake yi. So today the derivative in graphing. So today the derivative in graphing. So actually application is dama derivative mun san dy dx da yake da slope. Menene slope? Ko hawa ko gangare, right? So in slope is positive, that means hawa ne, like hawa. Slope is positive, that means when dy dx is greater than 0, that is the slope is positive. So hawa ne, hawa kuma that means, so that means the function is increasing on the interval. But when the slope is negative, that is less than 0, so muna da gangare wurin, wannan ne cewa the graph then function is decreasing in that. For example, look at this graph, maybe this graph. Mun san cewa if here is 2, here is 0, right? Here is 1, maybe here is 2. Mun san cewa graph din yana increasing. Here is negative 2, for example, sorry. Here is x, this is y. Muna cewa y tana increasing as x increases. So wannan graph din yana increasing this way, right? From negative 2 to 1, yayi sama, amma yayi ƙasa from this point to 1. So daga nan ma ya ƙara yin ƙasa kuma sai ya rika increasing. So wannan the inda ya increasing, the slope is positive. The inda ya decreasing, the slope is negative. Yes, inda slope is 0, inda babu hawa ba gangare kenan, like this point, the slope is 0. That means minimum point na graph din nan. Ko kuma na maximum point, relative maximum. Probably muna iya samun minimum point root 2, for example, if the graph is maybe like this. Ka gani nan muna da maximum point, ko nan ma muna da maximum, yasa muke kiransa relative maximum. But wannan shine babban maximum, so muna kiran shi absolute maximum. So in every case dai nan ma kuma minimum point ne, probably akwai wani minimum point na wannan absolute minimum, wannan minimum. So in every case dai at this point gaba ɗaya dy dx is 0. dy dx is 0. Ba mu da hawa, ba mu da gangare nan. So dole always idan muna son mu gane cewa yaushe ne graph yake increasing ko decreasing, sai mun san yaushe ne baya yin increasing. Sai mu ga what is happening after dy dx is 0 and what is happening before dy dx is 0. Let us say we have a function 3x, maybe y, 3x to the power of 4 minus 5x. Let me give a very simple example. For example, 2x square minus 4, or minus minus 4. 2x square minus 4. So in this case, yaushe ne graph din wannan function din yake increasing? So mu san yadda yake increasing sai mu san lokacin da bai komi. That means when dy dx is 0, irin wannan points din kenan. Inda ba increasing yake ba decreasing ba. So yaushe bai dy dx din ba, ko mu kira ta dy dx ko mu kira ta y prime. So this is at x minus 0, right? Because derivative of 4 is 0. So at this point, when this equals 0, when at x is 0, so solve for x equals to 0 over at this is 0. So when x is 0, graph din nan by increasing, by decreasing. That means slope din is 0 at this point. So let us see with a number line. Mun ce when dy dx is, here is our point, stationary point. When the graph din mu shine nan muka gano wannan point x equals 0. A nan ne graph din mu nothing happens to it, 0 ne. Slope din mu is 0 at this point. Graph din bai increasing, bai decreasing. So bari mu gani me ke faruwa in mun wuce wannan point din, decreasing yake a nan interval din. If here is infinity, here is negative infinity, a nan interval din increasing yake ko me yake? Let us try to test any number. Mun ce if dy dx is positive, so yana increasing. So let us try any number that is greater than 0. Let us say 1. Musa 1 cikin dy dx ɗinmu. This is our dy dx. Let us substitute 1 for x. 8 times 1, 8. Positive. Cool? So here is positive. This means our graph is increasing this way. Let us try any number that is less than 0. Let us say negative 1. 8 times negative 1, negative 8. Our graph is negative in this interval. So therefore, this is decreasing. So the graph is increasing on which interval? From 0 close interval, because the graph, the function is defined on x equals to 0. It is equal to negative 4 defined. So muna da wannan graph, wannan kind of brackets in there. So 0 to infinity, and it's not defined on infinity. We don't know because it increases without bound. So the graph is decreasing on which interval? From negative infinity to 0. So from negative infinity to 0, muna da yawancin square brackets. So the function number is defined at x equals to 0. So wannan abin da yake faruwa kenan. So concavity kuma wannan shine increasing and decreasing. Yaushe ne graph ɗinka yake 0? So test duka sides in wannan the graph ɗin. So what about this one? When y equals to 3x cubed minus 5x square, for example, what is happening to this graph? You're shaking increasing, you're shaking decreasing. Let us find dy dx first. Dy dx is equals to what? 9x squared, right? Minus 10x. When is this equals to 0? Your shake is 0. So it is equals to 0 when 9x squared minus 10x is 0. Right? Yes. When I factoring out x waje, when I 9x minus 10 is 0. This another case of quadratically one factorization method ne ke so an bi, so that can use any quadratic formula and so on to solve them. So this is equals to 0 when x equals to 0 alone, or when 9x minus 10 is 0. Then 9x minus 10 is 0, so that means x equals to what? 10 over 9. And okay, solving for x. So we have two values of x. So dole mu zana number line, mu ga me yake faruwa a intervals din. When x equals to 0, muna da x equals to 0, x equals to 10 over 9. Let me call it just maybe 1. Let me call it 1 because it's very close to 1. 10 over 9 is 0.1 something. Yes. 0.1 something. 1 maybe. I don't know. So let me simply call it 1. I'm not one exactly. So here is infinity already, here is negative infinity. 1 is one stationary point, and our function is defined on this. So square bracket. So what is happening between this interval to dy dx? Is it negative or positive? Any number that is greater than 0 but less than 1. Let me use 0.1 and substitute in my dy dx. 0.1 square. Well, it is easier in substituting into 0.9 times 0.1 nasan definitely less than 10. So this is negative, and negative times 0.1 is negative, so the graph is negative, it's minus in this interval. Any number greater than 2 would be greater than 1. Let us say 2. Here 2 times 9 times 2 is 18. 18 minus 10 positive. Positive times positive, positive. So the one dy dx number is positive. This is our dy dx one. dy dx. So it's positive. What is happening when this is negative? So negative 9 times negative number, negative times negative 9 number, positive. So this graph is positive in this direction. So what is this teaching us? The graph there is increasing. It's increasing on what interval? from negative infinity because it is positive to where? To 0. Union 1 to where? 1 to infinity because two intervals in the increase, but it is decreasing only on one interval. Oh, sorry, here we have this square bracket because the graph is defined at 1 and also at 0, x equals 0. So it is decreasing on what interval? From 0 to 1. So this is what is happening to a graph like this. So when a graph in muka lura ya saddo ƙasa haka, concave down kenan, in ya sama haka, concave up, yaushe ne haka yake faruwa? Well, we have to know yaushe yake canzawa, inflection point, lokacin da yake canzawa from concave up to concave down. So bari mu gani. So inflection point kuma still sometimes when muna gano concavity ne in general using second derivative, f double prime of x, using second derivative. So muna setting second derivative equals to 0. Sai mu gano me ke faruwa after shi da before shi using number line kamar in this case. In muka samu positive, well, this is positive, so therefore it is concave up. When it is negative, it is concave down. So yes, when it is, and also when f of x is here, muna the relative minimum. When it is positive, when it is concave up, muna the relative minimum. When it is concave down, muna the relative maximum. So we have to keep this in mind. So let us say one graph in the muka goge. Let us say 3x squared maybe minus 9. Y is this. Let me say this is 6. So, or 6x. So then gano yaushe wannan graph ɗin yake concave up ko concave down. Dole in san menene first derivative. 6x ne minus 6. Me second derivative? Oh, sorry. Let me say here I have 6x cubed. So the first derivative will be like this, 6. The first derivative will be 9x squared because 3 times 3 is 9 minus 1 from the power 2 negative what? 6. This is the first derivative. The second derivative is what? From the first derivative, this is 18x minus 0. So when I see the second derivative, she's me testing. Whenever, let us say yaushe ne wannan yake 0, that means inflection point lokacin da yake canzawa from concave up to concave down, ko kuma vice versa. So 18x equals to 0, that means x is 0 if you solve for x. So wannan shine dole mu zo a number line ɗinmu mu saka point ɗinmu x equals to 0, sai mu ga me yake faruwa da dy dx, d square y dx square, second derivative. When we use any number that take greater than 0, let us say 1. So this is positive. 18 times 1 is positive. So here we have positive. So it is concave up because positive answer. And also, well, if we substitute any number for x, we take a less than 0. Let us say minus 1. This is negative. So it is concave down. So the graph number is concave up our interval from 0 to infinity, and it is concave down from where? Well, from negative infinity to 0. So this is concavity. So in kana son ka gano relative extrema, that is relative maxima or relative minima, dole sai ka san point, sai ka san waɗannan points in critical points nan gaba ɗaya. When dy dx is 0 also, first of all, sorry, when dy dx is 0, waɗannan points ɗin dukansu dy dx is 0. So ya za a yi ka gane cewa ɗaya daga cikinsu wanne ne maxima, wanne ne relative minima. So in kai substituting points ɗin a cikin second derivative ɗinka, in ka ga cewa kana da negative answer, negative value na y double prime, so that means wannan point din yana faruwa concave down kenan in negative value. So therefore wannan point din is what? Maxima, because So in kai substituting a cikin y double prime wannan point din kaga cewa y double prime is negative, so that means concave down kenan. Firstly, point in da aka samu su daga first derivative ɗinka dy dx equals 0. If you substitute dy dx equals 0, ka samu probably stationary point ɗinmu x equals to 0 da muka gano a wancan previous example. So sai mu zo cikin the second derivative, mu substitute wannan x equals to 0. 18 x equals 0. 18 times 0, 0. Well, when dy dx is 0, it is inconclusive. So let us say it is 1. X equals to 1. So let us say stationary point on gamma when dy dx is 0 is 1. Okay. Same substitution in second derivative. 18 times 1 is 18. Positive answer. So to the positive answer, that means concave up. So to the concave up, we have the relative minima. So therefore, this graph has a relative minima at x equals 1. When idan muka substitute x, maybe at a stationary point mun samu x equals to -1. Sai mu substitute cikin second derivative x equals -1. Muka samu negative answer, so that means muna da concave down a wurin. So that means a wannan point ne x equals -1, there is a relative maxima because concave down there is. So this is all about this.